increase. Who's starting though? Alright, I'll start. I call going in. Alright, so we're ready to start. If you guys are, if you know anyone that's coming, let us know and we'll wait for them. Otherwise, we'll just start at 4:10.
Oh, message in chat. Alright. Boy. All right, everybody, let's start now. So, come on, go. Come on, go a few slides down. Go back.
Oh,
Yeah, all right. So this is the third and final hour for the Hack 3 Java workshop. I'm Veer.
I'm Surya.
I'm Khan.
All right, next slide.
Launch request.
Alright, so in this course, we're going to be covering.
Hot Express. We offer 5 different options at this time in either hot, iced, or frap. We have regular.
Okay, I don't know what just happened, but okay. So we're going to be covering. Alright. We're going to be covering arrays, array lists, class.
Hello?
Having trouble with our mic, Con. You want to start?
Sure. So we're just going to be going over arrays, array lists, some basic class structure, and then visibility and methods within classes, and then we can answer any questions you have after that.
All right, so I'll do this one. Okay, so arrays are a new data type. So if you were there in our first hour presentation, you know that we learned about primitive and non-primitive data types. So arrays are a non-primitive data type, and they're a way of storing data in the order that you put them in, kind of like a list or collection. So basically, you can store we can store many types of data inside of an array, including integers, strings, doubles, characters, and they're 2D arrays also, and we're not covering them now. But basically, what you need to know is that, as you can see in the picture, you can store like basically a list of values, and you can access them from the array using the indexes. So in code, indexes are like they usually start at 0. So the 0th element is always the first one, and we can access the last element using n-1, with n being the length of the array. So that means that this array is a length of 9, as you can see. So the last index is 8 because we start at 0. So we can move on.
Yeah, so in coding, basically everything starts at 0, and then, yeah. Another way to think of lists are, let's say we are, or can't go back one slide. So another way to think about lists, or sorry, arrays, is that if we have let's say a for loop or a while loop asking the user for an input, and we don't know how many times they're going to input something, but we need to store all of them. We use an array because obviously we can't make a new variable while the program is running and call it something else and then refer to it. So we just use an array, and we could store all the inputs into that one object and then refer to it at another point in time.
Yeah. So, but the thing is with an array is you have to initialize the size with the array. So you can't dynamically change the size of the array. So let's just say I initialize it to like an array length of 9, like as you can see in the picture. I can't put in a 10th element, or that's going to give me an error. We're going to cover something called an array list, which will allow you to store like a dynamic amount of values. So we'll go over that. But right now, arrays are pretty easy to use, and you can easily access values that way. So Colin, you want to go to the next slide? All right, so an array example. So right here, I'm initializing an array. So basically what we do is in this example, we're using an int array. So we say what data type is going to be stored inside of this array. So we're going to be storing a large like list of integers basically. And we're using the keyword new, which allocates some memory for this array. And we're giving it a size of 5. So we do new int array, and inside of the array brackets, we do 5. So for a length of 5. And to reference the number inside of the array, we specify the index. So if I want to store the first element, I create the integer first element, and then I point it to the 0th element of the int array. So as we said, 0 is always the first number that comes in the array. So whatever the 0th element of this int array is will be referenced and set to the first element. And the last element, same thing. So int array dot length. So the dot length method basically just gets the length of the array. We subtract 1, and that's the index of the last element, and we just set that to the last element. Yeah, and to set a value of to an index of an array, we can just, for example, if I want to set the first element to 0, I create the first element integer, I set it to 0, and then I do int array at the 0th index right there. So inside of the brackets, I do 0 is equal to the first element. So that's basically how you use an array.
Yeah, so you can set any part of the index to that. Let's say you don't know how long your array is. Like there in the example, it says int array.length. That'll just return the length of it. But note that'll tell you how many spaces there are open. So the index will always be shifted by 1, if that makes sense. So if we have an array of 9, all the indexes will go from 0 through 8, but the array.length will be equal to 9. So you would always have to do -1 to get the top index. All right, next slide, Tom. All right, so the next thing we have here is the array list. So an array list is basically an innovation upon the array. You can add or remove elements. It's an expandable array, and it is more versatile because you can obviously add or remove things. So the way you make this one is a little bit different. You do array list, then you put in like the less than and greater than operators. Use those as brackets, and then you put in a data class type, and then you give it a name, and then you do equals new array list, and then you use the same less than greater than, and then the parentheses obviously to call the constructor, and then semicolon. Yeah. So the reason that we capitalize the word integer and we wrote the whole thing integer and not int is because you can't put any primitive types in there. You can only put classes. You can only put classes or an actual like data type. So in Java, they've actually made like a class called integer, which represents the primitive integer. If that doesn't make sense, it's fine. Just know that you have to put the capital letter, and it has to be the full form of it. That's because, well, actually, that would be way too complicated to explain. But basically, just know you have to put in a class name here. And the benefit of this is you can make an array list of any.
And it's not built in, so you gotta import it.
Yeah.
With the import statement. All right.
You have to import the array list with that.
All right. Next slide.
All right, so adding and deleting items on array lists are done with two methods called add and remove. So first we'll look at adding items. When you make a call to add on your array list object, it'll add whatever you pass into this method to the end of the array list. So that's pretty straightforward. For example, if we ran this on an empty array list, ran these two calls, our new list would look like 8 and then 3. So that's pretty straightforward. When it comes to the remove, with integers it can get a little bit complicated because there's two ways you can call remove. You can either remove a value from an index, or you can remove an actual specific value. But since indices are integers, it's a weird distinction. So usually what you want to do is call the remove method with an index, just plain like an index if you're removing an index. But if you want to remove an actual integer value, you want to wrap it around integer.valueof, so it stores an actual integer object with 3. So if we had this 8-3 list and we ran remove 1, that would remove the item at the first index, or index 1, so that would be the second index, so the new list would look like just 8. And then if you ran the second one, which removes the integer with the value of 3, it would also remove that same one. So these two lines actually do the same thing. It's just a little different way of writing it.
All right, so this one is getting items. So it'll just return the index that it's in. So let's say you're writing a program and you're getting a bunch of inputs from the user. You could just do a get, and then the get will return the index of whatever input that you wanted. All right, so replacing values. So we can use the set method, right? So we could do dot set, and then we give it the specific index, and then and you tell it the other element you want to put in there. So it doesn't have to be an integer. So let's say you're using another data type. Let's say we haven't explained this yet, but we can make we can make data classes for like other objects, like let's say a person, right? A person would have a name and an age and an address, let's say, right? So we could replace that index with a whole nother object. It doesn't have to be a number. So if we did that nums.set 09 for that list 8-3, it would replace the 8 with a 9, so it would become 9-3. All right, next.
All right, so
one more thing I want to add is just like array lists, you can't use them like arrays where you can give it, put in the box brackets and put the index number and then get and set it. You have to use the methods.
all right, so assuming we'd have an array list of integer called nums with some sort of integers in it. This is how we'd use a traditional for loop like we learned in part 1 to find the sum of all those numbers. So we start a for loop with a counter variable I that starts at 0, and then we count up to the size, however many numbers there are in that list, and then at every iteration of the loop we're going to go to the next index, and then in every iteration we're going to add to this sum value that was initialized at 0 the value at that index I. It'll go 0, 1, 2, 3, etc. all the way until it's at the last element.
So let's say you're trying to calculate like the average. That's how you get the sum, and then you could just divide it by nums.size.
All right.
All right, so I'll do this one. All right, so methods are basically what allow us to split our program up. So like each method can provide its own function, and this way we're able to keep our code organized and modular. So if I wrote all my code in the main method and I wanted to change like the algorithm or way I'm calculating it, it would be kind of hard and unorganized to like change all of my calculation. But if I had a method, I could just change everything in the method and return the same type of value and not have to change anything in the main method. So that's a pro to a method. So basically, we have to first define the method's access, so who can call this method. Next, we define the return type of the method. What type of value are we giving back to the client code? And then finally, then we give a name to this method, and finally, we give it the parameters. So what values do we need to give the method in order to perform its task? So like if I was calling it from the main method, what would I have to give from the main method? For example, like user input or something, what would I have to give the method in order to perform its function? So we'll go more into that. If you don't get it just yet, we can keep going.
So let's say I had or if you go back one slide, Con, let's say I had a method called average, right? So I would write double average, and then I'd do an open parentheses, and I could accept an array list, right, of doubles. Here, I'm gonna write this in the chat. So I could accept an array list of doubles, call it nums, right? And then I put all my code in here. Okay, so I put it in the chat. So let's say I put all my code inside those curly braces. Basically, the first word is double because that's the return type, and so we can use that to take the average. So in short, we can use those methods. Let's say we have a bunch of array lists. We need to get the averages really quickly. We can just do average, and then we put that in, and it becomes really simple in our code. So we can like average 1 equals average, and then we put in the array list, and then we get it.
Yeah, so we're gonna go more in depth into that right now. So now you can move on to the next slide. All right, so a method can either be public or private. In this case, there are more things you can use, but they're advanced, and we're not gonna get into that right now. So for private, we generally use private to keep the access of the method only to other methods in the filer class, so that it cannot be accidentally tampered with elsewhere in our project. But public gives us the ability to call this method from anywhere in our project. So if you're not sure for now, you can just use public, but private is generally better if you know that you're not going to be accessing it from anywhere else in the project.
Yeah.
All right, let me do this one.
Sure. So the return type, like I was saying, so basically there's two returns that we can do. We could do a void return. So let's say we were making a game, and like we had like a character, and then he was going to go forward one step. We could have like a method just called forward, and then we do open close parentheses. It would just go forward. That's it. We could also do a data type of return, or return data type. So let's say the return data type was double, like in my example, average. So we could do a variable equals, and then that method, and that method would return a double, right? The average, and so we would store that. We would store that there. So instead of putting like, so we could use that to get a number. Basically, whenever it's done, it'll give us a value back that we can use.
Yeah, so if you're calling the method from somewhere and you want to get a value back from that method, you're going to be returning a data type, which will explain how to like actually implement. Otherwise, if you're just making a code or some sort of like change inside of the method, nothing has to be returned back to where it was called. You just use void. All right, next slide.
All right, so parameters are the next component of a method, and it's basically everything that the method needs inputted in order to give its output or perform its function. And so the parameter list is placed inside of the parentheses, or it can be an empty list of parameters. Just like that the average method that was posted in the chat, the array list called nums would be the one parameter that it accepts there, and then you can use those variables within the scope of the method and do whatever you need to with them and process them in order to make the output or do whatever the void function needs to do.
All right, next slide. All right, so methods and calling them. So now that you've written a method, you might want to like actually call the method so that we can use the value or something, or like actually perform the function. So assuming you want to call a method from the same file or class, we'll get into calling a method from a different file or class later on. But for now, we're assuming they're all in the same file. You can just write the name of the method with parentheses. So for example, my underscore method with parentheses, and inside of these parentheses, you must specify the parameters that you specified in the method declaration. So if I said in my method declaration that my method needed to take in 2 integers, then I would have to do integer, like I would have to input an integer and another integer into the parentheses separated by a comma. And here's an example. So if my method used a string and an integer, we would do hello, comma 1. So that's just one example of how you would call a method.
All right, so that must have been very confusing because here's our first example. So first we would give it a return type, right? Which is public. Then we give it a method name, so then we give it a return type, right? So we tell it, is it public or private? There's another one, protected. We could go into that after class, I guess. Then the return type, which is int, the name of the method, max, and then the parameters, right? So it takes in 2 integers, x and y. So whenever we call it, we would have to do max, open parentheses, some integer. You could actually write it there or use a variable, comma, and then another one. And then the curly braces represent what's inside of it. And all it does is it's returning the bigger number, right? Using that if statement and the else. It's basically returning the bigger number. So in my program, let's say I have 2 numbers and find out which one's bigger. I could just do bigger number or int bigger number equals max open parentheses my 2 numbers and then close. Let's go to the next slide. All right. So
all right, should I do?
Yeah.
All right. Okay. So basically, we have everything inside of one class, which is called example right now. Okay. So if we do. So we start off with our method age.
Oh yeah, this might be hard to read. So I put the link to the slides inside the chat. So
yeah, go to slide 43 if you're.
Yeah, it's on slide 43.
But so I can, if you guys want me to wait, just type in chat. But otherwise, I'll just keep going.
Yeah, just keep going.
All right, okay. So basically, what we're doing here is we got a private method called age. Okay, so basically we can make this private because we're only going to be accessing it inside of the class. We can make it public if we're going to be accessing it outside of the class, but we're not going to talk about that right now. So basically, when we're going to access it from the main method. I'm assuming you know what the main method is already. So that means that we have to use the keyword static. So since the main method is static, we also have to make this static. And then we specify the return type, which is a string. And then we call it our name. Obviously, it's age. And our 2 input parameters are int first underscore age and int second underscore age. And inside of our method, we're just checking with some if statements to see who has a bigger age. And we use an if statement, else if statement, and finally we use a return at the end if it's the same age. So basically, inside of the if statements, if it doesn't like when a method is when it's going to return something, it automatically exits out of the method. So once let's just say first age is bigger than second age, that means the first if statement is fulfilled and everything else after that is not run. So if everything else is run, so the if statement is run, the else if statement is run, and we see that, oh, they must be equal now. That's the only thing that can happen. We don't even have to do an else statement, and we can just do return same age. You can put an else statement if you want there, but it's just an extra line of code you don't actually need. So return same age is when they're equal. That's the only case that's left over.
So every time, the moment it runs a return line, the the method is terminated.
Yeah. And next we move on to our main method. This is where our actual like client code is, and we're trying to keep this as simple as possible by implementing methods right there. So let's just say I have 2 ages. I didn't do a scanner, but let's just say I set these 2 ages to 9 and 7. Since the return type I specified in my method was a string, I create a string called result, and then I call the method using the name that I called it, which is age. I do the parentheses and I put my 2 parameters inside, which are obviously 2 integers that I initialize in the 2 lines above. And finally, I just system.out.println my result, and it'll give you the result of which one is older, and obviously age one is older. So you can run that on your own time if you want on your replit, but your code is right there. So yeah.
All right, next one.
Okay,
Alright.
so do you want to go? Or,
No, go do it. You can do it. Go
all
ahead.
right. So now we're on to classes, which are really important to larger Java programs. They can be collections of methods, and they can represent basically an object in your program. So how you define it is with the class keyword, and then a visibility modifier before that, and then the name of the class, which would usually be capital. And then some components of a class are the declaration, which we just went over, where you'd say class and then the name of the class. The instance variables are variables that belong to an instance of a specific class. So let's say that we had a class called person. So we're all people with different variables. So we all have different names, ages, height. We could all have different values for those. So imagine instance variables to be an object's unique set of basically parameters. And the constructor is the method. It's a special method that will initialize an object of a class with those variables. And then instance methods will just be a collection of methods that we'll include in the class in order to, let's say, process any data about that object or get information about the object, set information about the object, and we'll go over more of how to use those in examples later.
Oops, we were muted. All right, so there's different access and visibility for classes. Obviously, there's the private and public. If it's private, it can only be in the same class, like we said. Public, you can reference it in any class or in any different file. Protected, like we were gonna say, is if it's declared as protected, it can be referenced in the same package through inheritance. So that's a little bit more advanced. If we ever do another workshop, we would explain that. And package private, it can be referenced. It's basically public in that package, but yeah, it's basically public in that package, but private everywhere else. All right, so classes, instance variables. So classes represent an object, right? Like in real life, like a person. It doesn't have to be real life, but and it would have the different qualities of it as a instance variable. So a person would have a name, an age, a height, a name, an address, eye color, right? So for all of that, let's say you were doing your program and you wanted to, there was a person object that you were making and you are passing that on to someone else, right? As if you were, so if you were passing that on to something else and you wanted to know the age of that, you could just do the name of that variable, the name of that object, dot age, and then you would find out what the age is for that. So basically what I'm trying to say is that every object will have its own variables inside of it and methods.
Yeah, we can go to the next slide. Oh, yeah. Wait. Oh, we're on that. Okay. So, yeah, as Veer was saying, so we can store the attributes of this person using this code, and we mostly just make it private. It'll make more sense later, but so we just store name as a string, which is
Wait, what just happened? Oh, you just rejoined.
Yeah, we're back. Sorry, I closed the tab by accident.
all right. Yeah. Okay. So as I was saying, we just store the attributes of the person: private string, name, private int age, and private double height. So for each person, we are gonna be storing their name, age, and height using this code.
Okay, constructors are special methods. They have no return type, not even void. And their main purpose is to give the class's instance variables actual values when they're instantiated. So the constructor just has a modifier and the name, which will be the same as the class name. And most of the time, you want your constructor to be public, depending on where your class should be used. An example of how we used a constructor, probably without knowing it before, in one of the other parts was when we created a scanner as a new scanner object, that new scanner system.in call was actually a call to the constructor of the scanner object. So it gave an instance variable of some input stream of value. And this is just an example of how we would create a constructor for our person class. So we have our 3 instance variables which don't have any values by default, but when a new person is created, you can actually input a string for their name, an integer for their age, and a double for their height. And what it'll do is it will set those instance variables equal to what you passed in. So you can create new person objects with all the details you'd like. You guys are muted.
Yeah, we were muted.
All right, my bad. Sorry about that. Okay, so instance methods, as I was saying, are methods or functions within a class that will process some information about the instance of a class and return a value. So basically, where you've seen this before already is scan.nextInt. So as you saw before, the scan object was initialized with the scanner class. So basically inside the scanner class, we're just calling the nextInt method. So that just creates an instance, and we just read the nextInt. That's basically what we do. All right, next slide.
All right, so this is an example of methods, right? So here we have an isAdult method, right? So we make a new person, right? And then we run the isAdult method. So if we want to know if they're an adult, we just do the name of the person, right? So, or the name of the variable assigned to the person, dot isAdult, and I'll return a variable. So you could do an if statement, right? So you could do if person dot isAdult, and then you could run code according to that. Like if you're an adult, make a bank account, I guess. Right. Next slide.
Okay, getters and setters are types of instance methods that are important to some types of classes because it's best practice to keep our instance variables private, but that means that you can't access them, whether that means getting them or setting them outside of the class. So if you want to be able to do that outside of the class, you would create methods such as set and a get method. So for the example of a person's name, if you want to do set name, you would accept a string parameter and then just change that instance variable name to whatever they passed in. And then for get name, you just return whatever their name is. So that's a way that's good practice to be able to modify or access instance methods outside of the class.
Yeah. All right. So to make our own person objects, right? So in the line we do person, right? And then we give it the variable, the name. We do equals, and then we use that modifier new. And new signifies to the compiler or to Java that we are making a object, so it reserves a new place in the memory for it. And then we do person, and then we're calling that constructor. So Khan, go back to the slide before. So you see that constructor there where it says public person. So that's whenever we make a whenever we're making a object of that. You see how it takes in 3 parameters: string n, int a, and double h, right? So n is name, a is age, and h is height. So go back to our example. Yeah. So here you're giving it the name, then the age, and then the height. So that's how we make it. So each of those variables, vir, con, and sur, they're all person. They're all of this same object person, but they all have different attributes.
All right. So finally, as you can, or if we go back up to the code that you had, you want to go back up to the
Where?
the code with is adult and stuff. Okay, yeah. So basically, we're checking vir.isAdult. So as we saw before, vir was set to the age 16. So yeah, and so basically we just check the Boolean is vir greater than or equal to 18, and he's not. So it's returning false. Then for the set name, we're just we're just making his name now not vir. So it changes vir to not vir. And finally, we do vir.getName, and since we just changed his name, we're returning name, and name was not vir, so it returns not vir. Yeah.
Cool. Next slide.
All right, that's all we have.
All right, we have to go to the last slide though.
Oh yeah. That's all we have for this. So if you guys have any questions, you can type them in the chat or talk.
Or we actually had an exercise.
We had an exercise. If you guys are interested in doing that exercise, you can type in chat. Otherwise, we're gonna end the session on.
Wait, actually go forward one slide. There's 2 more after this. No, after the end.
We're doing the exercise.
Oh.
Yeah, there's an exercise.
All right, if you guys want to.
If you want to, you can go to the
link at the end of the slideshow.
Yeah.
So we just sent the link in chat. We're gonna send a link in chat. Yeah.
Yeah.
You can go right there. We made an exercise for you guys. If you guys want to.
Yeah, and the answers are after there too. So if you go to the next slide, if you go to the very last slide on the slideshow, next slide. The answers are in those paste bins.
Yeah, and we created 2 classes. So if you're gonna copy paste the code to run it and check it, you have to create a data class and a main class.
Yeah, and you have to name it the same thing that I named them.
Yeah.
So try and do it without actually
copying, but yeah.
Yeah, that's where the answer is.
At least take a look at the exercise. If you have any questions, you can talk to us. Yeah,
we'll be here for the next 15 minutes, and if not, you can contact us on Slack. I'll put our names in there. And just message us on Slack.
All right, thanks for attending.
Thanks, guys. We'll stick around if you guys have any questions. But it's been a good session.
All right, see ya.
Bye, guys.